Bismillahirrahmanirrahim. This video is on the request of a student from Singapore, and here I will be solving practice problem 9.4 from Mr. Hayt's book of circuit analysis. So straight away to the question. Question says that sketch the voltage VR, which is given by this formula, and in the time range from 0 to 5 seconds. Part 2 is estimate the settling time, and part 3 says calculate the maximum positive value and the time at which it occurs. And the answers are given here. So the first part, we will try to sketch this. Now the book says that we first sketch the two terms. This is, for example, 9.4, but we'll follow same for the practice as well. First, sketch the two terms as shown in figure and then subtract them to find the value. Now, how do we sketch them? For that, what I have done is, one method is that I'm writing this signal, dividing this into two parts, calling this as V1 and the other part as V2, and then different values of T, so 0, 1, 2, 3, couple of values, and with the help of a calculator, I hope you can easily calculate these values. So these are the values that we obtained for V1T. And similarly, for the second part, V2T, we get these values. Now, we'll try to plot them, but this will not be very accurate. So I've taken a graph paper and marked this. Now, the first one is blue, starting from 2. Then at 1, it is at about 0.7. Then at 2, it is 0.27. So this is an approximate plot of the first one. And similarly, the second one is starting from 4, then 199 or 2, and then they're going down like this. So these two, now he's suggesting that you subtract these two to find the answer. So I guess it is very difficult to graphically subtract. So you can see from here, 2 minus 4 will be minus 2, and then the other points will be slightly difficult to do it. So what I have done is, I've actually calculated the subtracted value. So from these two, this is the subtracted value. And now we can plot this on the graph, and it will look something like this. So this will be a better way. But the best way is obviously to go or take help of the MATLAB. So this is the program I had written for MATLAB. And you can see this as a much better plot. And the answer given in the book is obviously much more clearer, but same type. Now the second part says estimate the settling time. Now what is settling time? Let's understand that. In practice, it is often desirable to have this transient response approach 0 as rapidly as possible. See this? This is the transient response and going down, and theoretically, this should be 0 at infinity. But what we want is that this should settle down as soon as possible. And so we have to make some approximation. The settling time is the time taken for Vt, the signal Vt, to reduce to 1% of the maximum value. So whatever is the maximum value here, when it comes to 1%, let's say here it is 1%, then that time will be the settling time. So for that, first of all, we have to find the V maximum. And I hope you remember from the calculus that to find maximum and minimum, we differentiate the signal and then equate it equal to 0. So we'll follow that same technique. We differentiate this signal. Differentiating and equating with this 0, and the time we are now calling it Tm, because Tm the time at which V will be maximum. And from here you can just follow these steps. I am moving this and then this, and finally taking the log because it is power of E. So the answer will be that T is 0.895. At 0.895, the signal will be maximum. So it will be somewhere here. And you can see from the graph, this is the maximum time at which the signal will be maximum. And now we can find the maximum value by putting the value of Tm in the Vm equation or the voltage equation. This was the voltage equation. So for Tm, we put the values, and the V maximum will be 0.544. And you can see from this graph it is almost 0.54. We have found the time at which it is maximum. We have found the maximum value, but we need to find the time when it is 1% of it. How much will be 1%? First of all, 1% of Vm will be this value divided by 100, so 0.00544. So I don't know, this will be somewhere here. So we have to calculate actually, can't guess. So we found 1% and now we have to find the time. So in this same equation, now we are putting the 1% value and we calculate the new time with this. This will be our settling time. So I'm writing ES. And since this is very small as compared to this one, this can be neglected. And from here, we'll calculate the ETS, and then TS will be 5.9 seconds. So you can see this is 5.0. So this is the point here, somewhere here, where it will be 1% of the maximum value. So this is the part B answer. And in the book also this has been given, 5.9 seconds. And now the third part, which we have already done. What it is saying is calculate the maximum positive value and the time at which it occurs. So we have already calculated this from, to recall from here, we found the P maximum to be 0.89 millisecond and V maximum 0.544. To match with the answer in the book, we just write it in milliseconds. Now this is in seconds, it will be 896 milliseconds. This can also be written as millivolts, so it will be 544 millivolts. And that is the answer given in the book. I hope you have been able to follow this. Please let me know through your comments. Thank you.